Welcome to SavoirLabs. I'm Jamie Goodger. Today we're going to talk about performance tuning our M4 Mac Mini for parallel requests on Ollama. Up next. Here in our lab, we like to use our M4 Mac Mini as an LLM host. When we're developing our applications, we will set up an AI on this machine and then we'll run through our various pipelines and workflows. One of the things we test often here is concurrency or parallelism, where we want to have multiple requests going into the back end and verifying that the system can scale out. Of course, if you're setting this up and you can only do one request at a time, that's going to be kind of tricky. Luckily, Llama supports parallel processing. Let's take a little closer look what this means. On the screen, I have 3 terminal windows open to our M4 Mac Mini, and I'm going to kick off a quick request to Ollama. We will see in this leftmost terminal, I'm going to ask Mistral, why is the sky blue? And if we were going to ask this many times, it would end up running sequentially. What we want to be able to do is have this running in multiple sessions for each of our users. So each one of these terminals, I'm going to kick this off, and we'll see that Ollama can do this in parallel. And we can see now that in all 3 of these terminals, we can see Ollama is responding to us, and we can see how many tokens per second it could process. Now that we have an understanding of parallelism in Ollama requests, let's take a look at the different parameters we can tweak to improve our throughput. The first variable is the max loaded models. Ollama supports having more than one model loaded into memory at a given time. For our testing, we're going to set this down to 1 so that we can guarantee we have the most memory space available for additional runners. Speaking of runners, we can set the number of parallel runners that can be used by the system. By default, Ollama will pick out either to use 1 or 4 runners. It'll use 4 runners when it sees you have plenty of system resources available for it. In our case, we're going to be pumping that way past that value. You can also set up the max queue size. So what does that mean? When you send in a lot of requests to Llama, it will start queuing those up locally and then process it as it becomes capable of doing it. So one job completes, it'll pick up the next one off the queue. We can also set the context length. That is the amount of tokens that the LMM is going to have available for it to think through your question, your request. So smaller amount of context, the less ability it has to think through things and process. More context, more time it can use, and more information it's processing. Very important though, if we are using multiple runners, every runner has to have available memory for that context to be processed. So the design of our test, what we have set up is a script, and you'll find in the show notes down below all of our results and a link to the script we use, that sets up a set of clients that will request to Ollama to run a query. Now, the way we're representing Ollama here is that we see it as being, we have our base service, and it'll take in requests, and then as we run out of active runners, it queues it down to its local queue. Very important for these tests is that we are looking at what we call the memory space. That contains 2 things. Your model, so we're always going to have 1 model in our test runs, and the number of contexts. So the contexts are equal to the number of active runners. 1 model with 1 context, 1 runner. If you have 8 runners, 8 contexts, and that will put more pressure on your memory. So the high level of this test, we are using an M4 Mac Mini base model, no additional memory. It's just the 16 gigs of unified that you get from the factory. We're going to test out Mistral 7B, Llama 3.2B, and DeepSeek R1 1.5B. There are many more models that you can take and different quantizations. This is just 3 that we have taken. Please, in the comments down below, if you test these out, share your results. We are going to always set max number of models to 1. We're going to try out from 1 up to 32 runners and see how that affects our runtimes. We're going to keep the queue size static throughout all of these at 512 and a context length of 2,000 tokens. All of our requests are identical, so we want to make sure that every one of these runners have the same kind of amount of work to do. And very importantly, the way Llama works is that to tweak these values, we have to stop export or set in the environment the new value and then restart Ollama for it to take effect. So there's always a restart of the service in between each test runs, so that eliminates any garbage collection that could have occurred, or artifacts from prior runs on our systems. So let's get into our results. Our first model is Mistral. It's a 7B model, and we ran this one all the way up to 32 runners. What we like to draw attention to here is that we found a sweet spot for performance at 16 runners. So if you are running the Ollama out of the box and it decides to set itself to 1, we would see that we have approximately a 71-72% reduction in the time it takes to process all 128 requests. Another way of looking at that is that it's about 253% faster at processing all of those requests, representing about 3.5 times improvement. Compared to if it was set to 4, we're looking at still around 61-62% reduction in time, about 160% improvement in throughput, or 2.6 times faster. All of this by setting one environment variable. So if you are setting things up and using this in your MacMini, you probably want to already have this switched over so you can get more throughput. Let's take a look at the Meta Llama model. This is a 3.2B model. When we were running through our tests, we found again that 16 runners was the sweet spot. It still had memory pressure such that there was plenty of space for all of its contexts. In terms of improvements, it's about 62-63% reduction in time compared to when it's just a single runner, about 55-56% reduction in time if it was set to 4, which represents about 170% improvement over single versus about 127% improvement versus 4 runners, which is still, we're talking about 2.7 times improvement to 2.3 times improvement versus the base case. Let's move on to deepseek. In the case of deepseek, and this is a 1.8B parameter model, we found that going all the way to 32 runners actually gave us our sweet spot for performance. We still have plenty of memory space left for all of our contexts, but we actually see here some of the best performance improvements. Compared to the baseline case of 1 runner, it is about 72%, still familiar numbers here, reduction of amount of time it took to process. If it was running 4, we're talking about 61-62% reduction in time. The other way of stating that is that compared to 1 runner, it's 260% faster. We get that much more throughput. In the case of just 4 runners, we're still talking 160% improvement in speed here. This represents a 3.6 times improvement, or a 2.6 times improvement when it's running 4 runners. All of this is to come down to say is that it is very much worth your time. If you are running a M4 MacMini and you are trying to do concurrent requests, start running a couple of tests and find out for your specific model, its quantization, its embeddings, everything that's specific to your use case. Start running through these tests and figuring out, 1 runner, 2 runners, 4, 6, 8, 16, 32. At some point, you're going to find out there's a sweet spot that you can get more performance. In the case of the M4 MacMini, I've found it to be about 16 to 32, depending on the model. So start testing. In context, though, let's just take a quick step back before we say, yeah, we have a surefire hit here. I have on the screen here a couple of quick comparisons. We have our M4 MacMini and our NVIDIA RTX 1000 Ada from our prior video. These are running the same models, and just wanted to try and show a comparison here. Even when we're running at the sweet spot of performance to memory pressure to number of runners, on the Mac system at our best performance, we're doing all 128 requests in about 250 seconds. The NVIDIA system managed to do it 194. In the case of our deepseek model here, again, same size model, same quantizations, etc. When we're running that one, we're seeing that the Mac could do it in about 61 seconds, where the NVIDIA did in 45 seconds. So yeah, the Mac Mini is very performant, and if we were to look at a cost for performance, it's still quite good because that NVIDIA card is just about the same price as picking up the base model M4. So yeah, that NVIDIA is absolutely faster, but we can still run some larger models on the M4, and we're not too far behind that leading edge performance. So let's recap. if you're going to take the script and try to figure out for your specific model what's going to be the sweet spot for the number of runners for parallelism, you're going to need to be editing the Ollama number parallel, keeping in mind that you also have to think about how big the context length is going to be for your application. So you're going to need to set that, set it to 8, and then give it a large, say 30,000 tokens, something like that. Set those up and run them, and run the test a couple of times to be able to find out how it performs. Keep in mind the nature of Ollama is that if it can't run everything, it could try and fall back into CPU modes. Just test out every permutation around yours, and you'll find where it's going to be optimum performance. As for max queue, I have to be very clear here that there's no quality service around this. If you are sending in requests and it's being queued up by Llama, at a certain point that queue gets full and it'll just start rejecting those requests. And also it's a case of that if they are in queue and you set that queue to a very large size, well, as soon as you send them in there, technically it's waiting around to be processed, and it could be several minutes before it gets picked up and processed. So there's not really like a priority lane or a quality of service to say that these messages have to be picked up and processed within so many seconds of reception. That is an area that your external application is going to have to handle. And with that, those are the key parameters we'd like you to tweak towards finding the best performance for your models running on your M4 Mac Mini. Well, it looks like we've ran out of time for this week's episode. Please remember to like and subscribe to our channel, and please comment down below. We love to hear any of the results and what kind of performance you're getting on your Mac Mini. Have a great day. Cheers.